For a decade or so, I've complained that physicists seem content with quantum mechanics as it is. They don't try to fix its problems. Rather, they tell themselves, and everyone dumb enough to believe it, that we must accept the quantum weirdness. By now, they've glorified the strangeness of quantum mechanics so much, it's become basically impossible for them to move beyond it. If something makes no sense, don't fix it. Give it a mysterious name and start a podcast. And yet today I have a team of physicists who've done exactly that. They've looked for the origin of quantum physics and found at least a possible one. That's intriguing because physicists said it's impossible. Let's have a look. One of the biggest mysteries on the foundations of physics is one you might never have thought about: causality. We're so used to it, we never even think about it. Flip a switch and the light goes on. Cause and effect, simple enough. Unless you have children, in which case the effect just happens and the cause denies involvement. But where does causal order come from? Why is the world so neat and orderly? The authors of the new paper say, actually it isn't. Causality doesn't fundamentally exist any more than, say, a liquid does. A liquid is fundamentally made of particles, yet the particles themselves aren't liquid. That just doesn't make any sense. The liquidness is an emergent behavior for a large collection of particles. The authors of the new paper say causality is like that. It doesn't exist on the fundamental level. It's an emergent behavior that we observe for many quantum particles. The reason I find this interesting is not just that it could explain the origin of causality. It's also that causality is one of the reasons why it's so difficult to combine quantum physics with gravity. Physicists have been looking for such a combination, a theory of quantum gravity, for almost a century. But the issue is that any such theory of quantum gravity is a quantum theory of space and time. This means that it must have superpositions of different space and time structures. But the space-time structure defines causality. This means that a theory of quantum gravity no longer has causality. It has what's been called an indefinite causal structure. You can't tell whether the switch turned on the light or the light flipped the switch, which doesn't just sound nuts, but it's hard to make sense of mathematically. The new idea of the authors could solve this problem because you no longer have to combine quantum physics with gravity. Rather, both could come out of one deeper framework that has no definite causality. Actually, the idea isn't entirely new. It's just that until now we thought it had been proved to be impossible. The authors of the new paper now say, yes, it's actually possible. Their paper's very maths heavy, but it works with what they call a quantum box, or Q box for short. This is just any kind of quantum event that can possibly happen. You can think of it, for example, as an interaction of elementary particles. These quantum boxes are connected without any particular causal order, so you don't know which caused what. The authors of the paper then show that to get any consistent physics, you need to average over one side of the box's input. That one side becomes the past, and they call this process hyperdecoherence. Okay, actually, it's not what they did. It's what I think they should have done. They just introduced this hyperdecoherence and declare that there is a past and a future. I think, though, that this isn't necessary. You just need a time order for consistency. I give this paper a 5 out of 10 on the bullshit meter. The good part is that they show, indeed, you get quantum mechanics as we know and like it. The bad part is that they put in too many assumptions. It's a bit like baking bread and saying you've discovered flour. So let me be clear, this paper is not a new theory of everything, but I think it's a step in the right direction. I've become very frustrated with physicists who preach quantum woo, like the idea that we can somehow erase the past with quantum magic, or that a particle and its spin can be in different places, or the particles have negative time and similar nonsense. What these examples all have in common is that if you actually look at the maths, that's not what it says. At this point, I think physicists are just making up fancy stories for their calculations to baffle journalists. In any case, I welcome this paper because it's trying to replace quantum physics with a better, more fundamental theory that hopefully will make more sense. Or maybe we'll just be even more confused. I used to receive a lot of spam calls after my cell phone number leaked, probably from some online shops that I used to use. This is why I've signed up to Incogni, who've been sponsoring this video and who've prevented this from happening again. You see, the issue is that each time you open a website, it'll try to collect data about who you are and where you are and what other websites you've visited. Many firms then make money by selling your private information to data brokers. Most countries have laws against that, and you can ask for your data to be removed, but doing this takes up a lot of time. Incogni automates the process of getting you out of those databases. You sign up and they will request that your personal details be removed. They'll keep on doing that, and if you want, send you regular updates. They now also have a custom removal feature where you can submit specific websites. I've been using this a lot. Incogni has really solved the problem for me. If that sounds like something you could need to, use my code Sabine or the custom link in the info, because the first 100 people to use it will get 60% off. Stay safe. Thanks for watching. See you tomorrow.